So getting some extra credit. So show me on your hands the answer to number 1. Give yourself a tally mark. Show me on your hands the answer to number 2. Give yourself another tally mark. Number 3. Excellent. 2 tally marks. Questions from anybody? Awesome. Number 4. Sine of 5 pi 6. So imagine a circle like this. A way that you need me to do it. Like this. Okay. So draw a circle. Count. I need to go 5, 6. So I go 1, 2, 3, 4, 5. Sine is always the up and down distance. It's the y coordinate. So because this point is above the x-axis, I know the value has to be positive. And because this is the short distance, and I remember the distances are 1, 2, 3, this is the 1/2 distance. So like this, you need more detail. Okay. Number 5, cosine of pi over 6. That's root 3 over 2. Positive. So like this, if you need me to do it, I'm glad to demonstrate. Cool. Sine of 3 pi fourths, that's over here. So that's up. So that's a positive, and the fourths are always root 2 over 2. Just wave if you need me to show how it's done. Okay. Simple definition of a function is list of inputs and outputs. The formula is how we calculate the inputs and outputs. The graph is a picture of the list. It's a picture of the inputs and outputs. We need more clarification on that. Okay, over here, number 10, question for the whole room. And I want to emphasize something. Okay, I think I said it a minute ago. Just kind of go a little deeper. Most people are really, really accustomed to math classes where you come in the room, you sit down, the teacher demonstrates a certain process, and you memorize, learn the process, then when he gives you the homework, it's like, I don't know, 10, 15, 20 examples of the same process. When they give you the test, actually they usually give you a practice test. You open up the practice test, you find, oh, that's the problems we did on day 1, oh, there's the problems we did on day 2, and you just do them again, basically. Like go like this if you can relate to this feeling. Okay? Calculus is very different. And I'm going to try really, really hard to get you to change your habits before the first test. This is going to sound a little harsh, but it is true. If you don't change your habits before the first test will change those habits for you. Because here's what's different about calculus. This is all just kind of memorizing process. It is. But when we start learning new calculus concepts, you have to focus on the concept. You can't focus on the process. Like this morning in first period, I was working on something. I was trying to help everyone understand an idea, and somebody asked a very legitimate question, like, well, I don't understand what we're doing. And I said kind of bluntly, as polite as I could, I said, we're not really doing anything. Like, we're not learning a process here. I'm trying to help you understand an idea so that you can then apply that idea to problems. The reason I have to do that is the tests in this class give you this really uncomfortable feeling. They give you this feeling of, we didn't learn this. I'm serious. Like when you take the AP test, that's the feeling you're going to have, is like, wow, this is different. But the reason the class has so much value is, in industry, no one wants to pay you to do the same thing over and over again unless you're happy to be earning a very low salary. Like if you're a professional, they want you to solve new problems. Like I didn't work at Larson Davis. They didn't bring me things that had been solved. They want me to solve new problems. And they don't want me to go to my boss and say, I don't know how to do this. That's why he gave me the project. He doesn't know how to do it either. He has to figure it out. Another example, my wife is an ICU nurse. They recently had to let a couple of young nurses go. Like they were on the unit for about 6 weeks. They were trying to train them how to be an ICU nurse. And the problem they ran into was these two nurses were just too accustomed to always following the recipe. Like doing whatever the book said they were supposed to do. And when they got in a real life situation, they couldn't adjust. Like they couldn't think and adapt to the new situation. So they couldn't work there. So calculus has great value in my opinion because it forces you to change the way you think. Instead of just copying what the professor's doing, you've got to understand what's going on so you can solve new problems. The great benefit is it will put you way ahead when you get to college. Had a student about 4 or 5 years ago, her name was Emily Morin. She sent me an email from Utah State, and she talked about her psychology class of all things. Totally different than calculus, right? In her psychology class, she noticed that after about 2 weeks, a large number of students in the class were complaining vigorously that the professor was unfair, that they couldn't figure out what the heck they were supposed to be learning, they're all doing badly on the quizzes, whatever. Emily was doing really, really well. And what she figured out was that all of these other students had not made the adjustment from just copying information to really understanding information. Okay? And so she had a huge head start. It really will make a difference. But anyway, so as we're working together on this, I just have to keep pushing you to do that, to make sense of the ideas. Back to this. So I want to ask a question that relates to understanding what we're doing, not just copying what we're doing. And I want to get your feedback on it. Oh, that's why I told the story. I got lost for a minute. I apologize. It doesn't matter if you have a right or wrong answer in this room at all. What's important is that you're participating, like you're with me, you're trying to make sense of it. If you have the wrong idea, that's fine. That's why you're participating, to get that fixed. So a lot of times when I ask a question, don't stress about whether it's right or wrong. Just answer as best you can. If it's right, great, it's positive feedback. If it's wrong, great as well. Because now you've figured out, oh, I didn't understand that, and then we fix it. Okay, so that's what I want you to feel like in this room. Quick question. I asked this in first period, and about half the class was kind of mixed up, so that's why I'm asking it again. We're supposed to find G of 3. Every single calculus problem is always a set of inputs and outputs, and you've got to be able to keep them straight. So do this if you believe G of 3 is an input. Do this if you believe G of 3 is an output. So what are they asking us to find? Are we finding an input in the list, or are we finding an output in the list? This means we're finding an input. This means we're finding an output. It doesn't matter if you're right or wrong. All that's important is that you're trying. It really is. As long as you're trying, you'll be learning. So everybody who tried, give yourself 2 tally marks. The correct answer is you're finding an output. The symbol G of 3 means output. So when I write on the board G of 3, and then I write equal, equal isn't a pointer to an answer. Equal means these things are the same. They're equivalent. So G of 3 means, hey, here's my list of inputs and outputs. Go to where the input value is 3 and identify the corresponding output value. So G of 3 has a value of 5. It's definitely an output. Questions about that? Awesome. So the correct answer is 5, but it is an output value. Now they're going to ask us to find an input value, because they're saying, hey, I want you to identify the output of 8. G of x means output values. So when the output value is 8, the input value is 0. Question? Cool. They asked for the average rate of change over this interval. So what you should have been thinking is, let's see, I need to find out how much the function changes over this interval. So at the start of the interval, the function's value is 7. At the end of the interval, the function's value is negative 20. So that means the function is going down. Oops, I went to the wrong place. My bad. Sorry. We stopped here. So at the 8, the function has gone down by 15. So 7 down to 15. Let's see. That's a drop of negative 22. And then that occurs over an input change from 8 to 2. The input's going up. So when the input goes up 6, the output drops 22. So this is a perfectly valid answer. Because on the AP test you don't have to simplify. If you chose to simplify, it is also valid. Either one. Please.
So it's always input over output?
Other way, sorry. Always output over input. So whenever they say find a rate of change, they always want how the output is changing relative to how the input is changing. And that's just arbitrary, Elijah. That's somebody decided to do it that way. So anybody else? 2 for Elijah. Cool. The last one talks about finding the average rate of change of oil leaking from a tanker. So let's see. We go find how much oil has leaked after 1 hour. So that's 3, plug in the 1. So 3 gallons have leaked after 1 hour. We determined that after 3 hours, 27 gallons have leaked. So that means that during the 2-hour period we are interested in, 24 gallons have leaked from the tanker. So on average, we're losing 24 gallons every 2 hours, which means on average we're losing 12 gallons per hour. Either answer is correct because simplification is not required. Please.
I forgot to put units.
Oh, gotcha. If you forgot to put okay, let me explain how we grade, and then that'll kind of fit in. So the way you grade the quiz is you don't count up points, you deduct points. So it's kind of like Olympic gymnastics. So that wasn't very funny. Okay, so just deduct. So like if you miss a question, you take off 1. If you got the question right, but you only got it right because you worked with somebody else to help you, you take off a half. Does that make sense? So down here, if you forgot the units, take off a half.
Okay.
Now, at the end, you just say, okay, I lost whatever, like, I don't know. So if you ended up with a score of 7.5, because the quizzes really are just about learning, I'm not that concerned about the score. It's only 10% of your grade, that sort of thing. Round up for the final score. So this becomes 8. So if the only thing you did wrong on the whole quiz was you forgot the units, you're actually going to get 10. Does that make sense?
Yeah, that makes sense. Thank you so much.
2 more for Maddie.
Thank you.
Anybody else? Oh, please.
Wait, can you do show me why number 2 is a negative 1?
Right here.
Yeah, because wouldn't you why wouldn't you just cancel out the denominator e and just leave the 1 on top?
Oh, I got you.
Yeah.
Okay, Brennan Dahl, right?
Yeah.
Okay, sorry for the name thing, it just helps me. So, let me get a screen here, Brennan. Four tallies for Brennan. You asked a question in a really helpful way. You really did. That's why I gave you 4. So everybody eyes up. Like everybody watch this, everybody. Okay, the mistake you're making, and again, it's no big deal to make a mistake, but it just helps to point out what it is. Okay, the mistake you're making is you've got in your head that this operator and this operator cancel. I think that's what you're thinking. I have a
Isn't there,
little.
like log E,
What's that?
like log E.
Right. You're on the right track.
Yeah,
You're on
so
the right
that's
track.
why, yeah.
Let me throw in a couple things here. This is just my pet peeve. I kind of make a big deal about it. I personally don't like the word cancel because it conveys no understanding. And this class is all about making sense of things. Like if you just learn steps, you really are going to be in trouble, I guarantee it. So I won't use this word hardly ever. Once in a while I find a place where I go, okay, I think that's the right use. What we really are doing here is we're using a specific identity. The formula you're using that's in your head is this one. Natural log of e to an exponent. Like 8 is just 8. So it's totally understandable that we kind of think of it as canceling. I get that. But it really isn't. It's like using this identity. And this identity doesn't fit. So here's the more generic form. Written like this identity doesn't fit because it's the natural log of e to an exponent. Well, this is the natural log of 1 over e. It's not e to an exponent, so I can't use this as is. You with me?
Yeah.
So what I do instead is I rewrite 1 over e. So there's another identity that says 1 over e to the, like that, is the same as this. And that's the same as this. So that's what we do first, is we change to that form.
Because then you can like use that.
Jackpot. Does that make sense?
Yes.
Perfect. In this form, that's why I don't like the word cancel. Because it leads to that kind of a mistake where you kind of just get mixed up and think, oh, these just cancel, and they don't. But we convert to the other form, now the identity works perfectly. Did that help?
Yeah.
It's perfect. Please.
I just have a quick question. Sorry, going back to like number 6, I don't get why it's like square root of 2 over 2 because like when you do the circle, is there a square root of 2 that I get?
You're okay. So, no, don't worry, Allison. 3 tallies for Allison. No, your question's perfect. Everybody, here's what I would always do. Again, we're trying to get to the point where getting from here to here, here to here, here to here is just kind of natural. Like about as easy as 7 times 5 is 35. You just kind of do it, you don't worry about it. So what I want you memorizing to start with is, whenever you're making these conversions to this, it's always going to be 1, 2, or 3. 1, 2, or 3. It's really 1/2 root 2 over 2 or root 3 over 2, but it's 1, 2, or 3 kind of helps me remember. If it's a 1/6 or a 1/3, so I didn't do a 1/3 as an example up here, but if it's a 1/6 or a 1/3, it's always going to be 1/2 or root 3 over 2. Always. If it's a 1/4, it's always root 2 over 2. So when I draw the circle, and I count 1/4, 2/4, 3/4. Because the fourths always land right in the middle of an arc, the up and down distance and the back and forth distance are always identical, and they're both root 2 over 2. Sign is up and down, so because that's a positive direction, that stays positive. I don't know if that helped, Allison. Okay. Anybody else? Cool. Ask your sister Anne if she likes to go to Jason's house and eat sausage. No, Jason likes to come to your house and eat sausages. See if she laughs. Inside joke. Okay.
Is there like Jason King?
Yes. I still remember talking with he and Anne one day. He's like, "Yeah, I remember when I was little, I would always go to Anne's house and eat sausages." I don't know what that meant, but he was pretty happy to share that. So. I was such a happy little kid eating sausages at Anne's house. Allison's laughing, so there must be some humor behind it somewhere. So, okay, very good. All right. Other questions here? Perfect. Okay, so you grade your own. Questions about the scoring. Keep the score. I'll pass a clipboard next time. You'll just write down the score. okay? Because again, it's just about learning. Let me show you another thing. All right, so let's jump to here. So today, we have about 20 minutes before they'll probably get on and tell us to go to the assembly. Although sometimes it goes a little bit longer, so we'll take whatever time we have. Today we start discussing the very first calculus topic. And I need to emphasize again. So eyes up here, eyes on me. Okay. When we're discussing, you got to keep separate when we're trying to understand something versus when I'm kind of showing you a process, because there are processes to learn. But you cannot, I plead with you, you cannot say, I'll pretend to listen to the process, but all I really care about is the concept. Because I've been taking math for, I don't know, skipping elementary school, I've been taking math now for 6 years. I know how this works. The teacher always says the process is important, but they always say the ideas are important, but they only test me on the process. I guarantee it's not like that, okay? You'll be very sadly disappointed. You've got to understand this first. If you understand this, the process becomes easy. And then you're not fooled by the questions that you get on the test. Because of that, I do a couple of things to help with that. One, I will periodically tell you, I don't know that you should take notes right now. I think it's better that you really focus on the discussion, make really good sense of it, and then if we need to pause for a minute while you kind of write down what you've made sense of, it's totally fine. But sometimes if you're trying to take notes and make sense at the same time, difficult, right? You can't process both. The other thing I do is I make a video. It's not really a video. I make a recording of every discussion, and then you can go back and watch it if you need to. Or if you happen to miss class, that's what you're going to do first, is go watch that video, and then you come talk to me if you still need help. Just so everyone can understand where to get the video, you go to the school website. It wasn't working before. Let's see if it's working now. Establishment, waiting, still waiting. It's very exciting. Still waiting. Cease to be exciting now. There we go. World's slowest website. That's not the home page, but close enough. I don't know why I did that. Now I have to wait some more. Great. I will assume you know how to get to my picture. Choose the website. You'll go to here. Now the good news is that I lucked out. When I set up the website, I used Blogspot, and no one had used my name. So I get the name, Craig B. Smith, that's my full name, .blogspot.com. So if you don't want to go through the school website, it's on the disclosure. You can just type that in, it goes right to it. Once you're here, just choose Unit 1. And I think I've got my iPod plugged in, so this volume might be kind of low, but then just choose whatever day you want to watch. So when you're looking at a graph, you're just seeing a picture of the inputs and outputs. You can hear Mr. Recty's class at the same time, which is kind of annoying. But so I tried to make this the reason for that to memorize. The reason for that is quick story. So what I do actually is it's not really a video. You see whatever happens here. If I come over to this board, you can't see it anymore. So I try to stay here as much as I can. And then you hear the audio in the room. And I use this device. there we go. The first year I'm teaching, it's October, it's Halloween. I've never been one who was really comfortable dressing up, although now working in a school I've tried to be a better sport and think of something to wear. But the first year I was like, I don't know what to wear, so I came up with this really lame idea. I wore my company shirt, so it said Larson Davis. I brought like a bowl of candy, and I brought business cards. And at the start of class, I walked around to every student, gave them a business card, I gave them some candy, and they're like, what are you doing? I says, well, look over at the bulletin board. It's a little hard to see, but this is me in Dallas, Texas, at a trade show. Like that's some of the things they had me do. I go to the trade show, right, and talk to people, and that's what you do. You give them your business card, you give them a piece of candy, and you try to get them to learn about your product. So that was kind of a lame Halloween costume, but anyway, here's the more interesting part of the story. So I did that first period, kind of prep second, did it third period. Fourth period I did it again, and it never really was that exciting until something happened. Fourth period, one of the kids in the room, he's looking at my business card, and he raises his hand, he says, Mr. Smith, what would happen if I call this number? And I'm like, well, I'm not kidding you, I really did work there. It's a legitimate business, I didn't make this up. Go buy a shirt and business cards, you know. Go buy that at DI or something. No, it's real, it really works. I said, they'll just say, this is Larson Davis, how can we help you? It's a business. He's like, oh, okay. So I go back to teaching, right? Well, I notice, I kind of just pay attention, and I notice he's over there on his phone. and I just kind of let it play, because I was kind of curious myself. And so I kind of just watching for a second. He's over there, he's like, I want to buy some merchandise. And then some other kid, they're all watching him too now, you know. And some other kid goes, gets this gleam in his eye, and he's like, let's all call. So seriously, like 20 people, all of a sudden, all of them whip out their phones, and they're like all dialing Larson Davis. I couldn't stop laughing for like 5 minutes. So after 5 minutes, get everybody off their phone and get everybody calmed down. At the end of class, I just was still laughing. I call Larson Davis, a guy I know, because there's only 50 people there. It's a small company. Everybody knows everybody. He answers the phone. He's like, oh, Craig, it's good to hear from you. How's your new job going, you know, and everything. And he's like, wow, the weirdest thing just happened. So that was pretty fun. So. I don't know why I'm telling you these stories. Anyway, that really doesn't have anything to do. Oh, the website. Yeah, we use the microphone for the website. Questions about the website. So, okay. So what I want to talk about now is the first topic here that we're studying is known as limits. So this is the first calculus idea. You don't need to worry about that. You'll remember that easily. No one ever forgets that we're studying limits, okay? So for a moment, don't take notes. Just kind of watch, but make sense of the idea. Because if you make sense of what I'm about to discuss, you will never, ever have a problem with solving a limit question that involves a graph. I guarantee it. But if you can understand how to read a graph properly, and if you will pay attention to whatever questions are popping in your head and get those answered during our discussion, whenever you see a graphical limit problem on the AP test, you'll have no problem. Okay? It's all about understanding how to read a graph properly. So we're going to start with this one. And I'm going to modify the graph a little bit because the one they gave me isn't quite what I needed. These are all actually from old AP tests. Every one of these came off an old AP test. So let's make this a little bit bigger. That's pretty good. I want to change this closed dot to an open circle. So you kind of have to imagine a little bit. That's not filled in. That's open. This one's filled in. This one's filled in. This one's also filled in. Okay, y'all with me? Here's how you read the graph. You remember, a graph is just a picture of the inputs and outputs. You should also remember me saying that when I look at a graph, I don't see a curve. I see an infinite number of dots. And the first dot I see is right here. So there's no dots over here, which means if I were making the list of my inputs and outputs for this function, so my inputs are x and my outputs are f of x, there would be no inputs at, say, x equal -3. And there's no input at x equal -4 or -5 or whatever, because they're not shown as dots on the graph. Questions about that? Cool. Now they make that a closed dot for this reason. If they had drawn the graph like this, with no closed dot, it becomes a little bit, I guess you guys would say sketchy is still a word. Teach for 15 years, the slang is really hard to keep track of what's current. So anyway, it's a little bit sketchy, it's a little bit ambiguous as to where does that thing start. So they put a big dot so you can immediately identify, oh, I can see exactly where the graph begins. And they're not going to do something unfair. They're not going to make it begin at -2.516. Okay? It's just a graph. They always make it start at a nice, easy to identify location. So the very first dot is at an input of -2 and an output. They didn't put a scale here, but it appears to be -1. So you can be assured that when there's a large dot, it's easy to identify. It's not hard. Everybody with me? So the first item in the input-output list is input of -2, output of -1. X equals -2, y equals -1. That's why they do the dot. There's a whole bunch of other dots through here, an infinite number. That's why they don't draw them as dots. Because how do you draw an infinite number of dots? You can't. So they draw a line instead. But really, you should be seeing dots. It will really help. I'm not going to list them all because there's too many. So I go to the next interesting place, the open circle. The open circle is to emphasize that there's nothing there. They could have drawn it like this. Let's redraw this for a second. So they could have drawn it like this and just kind of stopped. But the trouble is, there again, you can't really tell where the thing is stopping. So they'll put a nice open circle at a nice, easy to identify location to say, hey, that's where it really stops. There's nothing there. It's missing. There's nothing there. There's no dot. So don't ever think of the open circle as a dot. It's the absence of a dot. So I actually have my own invention here. I've never seen a teacher do this, but I'm hoping to get a patent. No, patent's the wrong word. Trademark, yeah, the copyright, something like that. This is my own invention. So I draw a ghost dot because there's nothing there. So I think it's kind of clever. I'm kind of happy about this, actually. It's a useful teaching tool. It takes a long time to draw, but you have to draw them very large, which looks kind of awkward. But so. That makes sense. So there's nothing there. There's no dot. You don't come down here and put 0, -2 because that's not in the list. Question. Anything coming to mind from anyone? Do we need to write anything down so far as it feel like the kind of thing that's intuitive enough you don't really need notes? If you need notes, take a moment, write down. Just kind of watch and you start writing, I'll pause. Okay? So we've got the first dot. We've got a whole bunch of other dots. We suddenly see that there isn't any dot. Okay? Now, no one asked this question. They asked it last period, so I'll talk about it. Somebody said, well, why do they even, what's the point of that? Well, the reason for having the open circle is so you can identify the very last dot that's just before the missing dot. Okay? So if you look at the graph, the way you read that is you say, well, we don't have a dot at x equals 0. But there's a dot right before that. So there is a dot at this point. Let's see, I gotta get some space. Make that bigger. The location of the dot that's right next to the circle, that dot's location is this. Back. Negative. Now we'll play a silly game. I'm trying to get you to understand where the dot is located, okay? The x coordinate of the dot. The x-coordinate of the open circle is exactly 0. I'm trying to get you to see what's the x-coordinate of the dot that is located just before the open circle. And it's not really possible to see because we have to zoom in a trillion times to see it. But I'm trying to get you to see the x-coordinate of the dot that's really close to that open circle. So I'm saying that it's going to be negative 0.00000. I was trying to get away to this as a game, but it's not really working, so I'll just keep going. 0, 0, 0, 0,
Would it
please.
be a number of zeros because it's just like connecting on zeros and then a 1?
That's as best I can conceptualize it.
Yeah.
Yeah, that's not really right,
Okay.
but I can't think of it any other way because I'm a finite human being and I don't really conceptualize infinity very well. But that's how I think of it. Is you would go zeros forever, and whenever forever ends, which doesn't make any sense either, then you put a 1. But that kind of makes
Yeah,
sense.
that makes sense.
Maddie and I are good. Anybody else need help? Okay. Questions? That's the idea. That's the point of the open circle. Is so you can quickly say, oh, there isn't a dot at 0, but there is one just before. And because that's really annoying to write, some people said, well, can you do the bar thing or whatever? That's a little sketchy too. So there's a symbol that math teachers use. It's this. It's not 0. It's just barely negative of 0. So this means this. So this is a negative number. It's not 0. That would probably be good to write in your notes, that this and this are the same. Yeah, please, Hayden.
So would you put that point in your inputs and outputs over there?
Absolutely. So if you're listing all of the points that are in the input-output table, 2 for Hayden and 2 for Maddie, there's a bunch of missing points we won't write because there's too many. But eventually we would get to a point that is just barely negative of 0, for sure. Is that what you meant?
Yeah.
Perfect. Anybody else? Oh, please.
So then when you're writing the output for like that is negative, it's right or negative 2, do you put like is there a symbol for that or do you just
Outstanding. 2 for Avery. That's the other purpose of this open circle. The open circle has a y value of negative 2. Now, look at me and picture this. If you picture it, it's a lot easier. So here's negative 2. The dot that we know is part of the function happens to be just a little above that. So it's not quite negative 2. It's like a little above. So it's actually a little positive of negative 2. So we write negative 2, a little bit positive. And it's really can be thought of as this number. 1.9999 forever. Because it's not quite yet negative 2. Please.
So can you do that with any of the numbers, like the negative 2 positive? That's reaching any.
Yeah, now these are not official numeric values. Like you will never write this as an answer on any sort of test. And you'll never see it as an answer. It's more of a way to communicate with each other without having to write all these decimals. Does that make sense?
Yeah.
Did I answer your question, Michaela? I wasn't
Yeah.
sure. Okay. 2 tickets, 2 tallies.
So back to the 0 and the negative next to it, that's the same as that. Like if it was positive, would it just be a plus sign right there instead of negative?
Yeah, let's jump over to a new board here just to make it easier to talk about. Hold on. So you've got the idea here. This number that's just barely negative of 0 is equivalent to this symbol, just barely negative of 0. This number that is just barely above 0 can be expressed as just barely positive of 0. This number that's not quite yet negative 2 is a little bit more positive than negative 2. So you write it like that. This number is a bit more negative than negative 2. So you write it like this. A bit more negative than negative 2. Question, please. Thank you.
So you said that you never put that as an answer. Will that ever be in like the question when they ask you that? Like, will they ever use that?
They use this symbol for a slightly related, yeah, it does show up in the question.
Okay.
Yeah, so we'll kind of, it's easier to wait until it actually shows up to give you more detail. But yeah, you will see that notation.
Okay.
But you won't ever write this as an answer. It's more of a tool to just help you understand what's happening. Does that make sense?
Do you have the recycling?
Not today. Thanks, Caitlin, though. Anybody else? Perfect, 2 for Danny. Okay, so back here. So again, you're doing really well. That's the whole point, is make sense of how to read the graph. And it's one of those weird things that, like, I don't know, to me, once you've got it, you've got it. And then you're all set to answer a bunch of questions. You just don't want to focus on the questions yet. Focus on how to read the graph. Is everybody with me? Perfect. Okay, so if we're looking down this list, we're reading the graph from left to right. We got to here. We know there is no dot at 0, -2. But there was one just prior. And that's back to Maddie and I's conversation of what the heck does just prior mean? Well, do your best. Okay, infinitesimally close is really hard to wrap your head around. So I think of it exactly how Maddie did. Okay, I can think of that. That's not too bad. It just means I'm not quite negative. I'm not quite 0 yet. So I'm really this number. And I'm not quite all the way negative to -2, so I'm that number. Good enough. Question. Perfect. As you read the graph, you keep going left to right. So the next dot is up here. And it is located precisely at x equals 0. And based on the scale, it looks to be at y equal 1. So that's the very next dot in the list. That one's easy. Please.
So how many like functions do you put, or like how many are we supposed to do? Like, are we just doing the ones on the dots, or like?
Keep talking, Nelson. You're doing great.
Anyway, I'm confused because
Okay.
like, do we do like you don't have to do all the minuscule dots, do you?
Like all the ones that are here.
Yeah.
Oh, gotcha. Perfect. So I typically won't write all of these because there's an infinite number. And so I'm just trying to, in my own head, I'm just trying to get a sense of what am I looking at.
Yeah. So do you just do like the whole numbers?
I mostly focus on just the big points.
Yeah. Okay.
Yep, perfect. Doesn't mean we couldn't focus on the others if we needed to.
Yeah.
But right now I'm just focusing on kind of the big points. Does that help? Perfect. 2 more. Anybody else? Awesome. Okay, so I'm kind of running out of space here. There's a whole, well, let's go here for a second. Okay, so there is a dot right there at 0, 1. There's also a dot right there that is infinitesimally close to the dot at 0, 1. It's infinitesimally close. So checking the room to see if we're all together, raise your hand if you know how to write the x-coordinate, input value, x-coordinate of the red dot. This is how we're trying to show you know how to read a graph properly. What would be the x-coordinate of the red dot? Raise your hand. Again, I don't really care if you're right or wrong. I care more that you're trying. Sometimes you draw a blank, I get that. But best if you can kind of think, well, I think it's this, and then if you're right, great. If you're wrong, who cares? That's why we just talk back and forth a lot. So, Cass, what do you get?
Is it like 0 with the plus and then 1 with the plus?
Perfect. So the x-coordinate was 0 on the green. The red has got to be a little more positive. So its value must be just a little bit positive of 0, which means, for reference, that would be this. Okay, good there. And then Kess said, well, if the green dot has a y-coordinate, an output of 1, the red is certainly higher, more positive, but just barely, just an infinitesimal amount. So, like that. And that means this. Like that. So how many were thinking what Kess was thinking? Show me your hands. Give yourself 2 tallies. If you're thinking something different, give yourself 2 tallies as well. Because I don't care right or wrong. I just want you to participate. I just asked how many knew so I can get a sense. So, please.
So like, I know you never really use this, so that's just like 1 over. Then how would you write like if you really want to, but one just over.
One more than that?
Yeah.
I guess they would go like 1++,
Okay.
but I've never seen that notation. So, but that's how I would think of it. Yeah. It's a good question. 2 more. Anybody else? For the purposes of this class, you're right. They don't push you to think that deeply about it. They leave that for more of like a graduate level mathematician in college. So. Awesome. Cool. That's about as far as I wanted to go today because I kind of planned it out for the assembly. I don't want to get too much further and then they suddenly get on the intercom. I cannot remember if we did the music quiz in this class as an activity or not. Oh, we'll do it again. Okay, cool. So, no homework tonight. Look at me. Look up. Look up. Because I stress so heavily that it is crucial that you understand the idea first before you worry about how to solve particular AP problems. This is not uncommon for my class. I will spend a pretty good amount of time, and as you notice, I hope you notice, when we're discussing, I'm really trying to focus on you, not here. So that sometimes means that we just don't have time to get enough of the understanding to really give you problems. And I hate, anyway, so no problems tonight. Okay, cool. Hold on.
What?